Ratios and Graphs, Topic 13-3B, Envision Math 6. How can you use tables and graphs to compare ratios? We're going to build on what we learned in Topic 12-1 with ratio tables, and now convert these tables to graphs. So first, we want to see how is a ratio table different from a regular table. This is a review. In our ratio table example, we can see that 1/3 is equal to 2/3, which is equal to 3/9, which is equal to 4/12. Every ordered pair is proportionate. That means they are equivalent. They all reduce to the same ratio. However, in our non-example, 1/3 does not equal 2/4, which does not equal 3/5, and so on. Every ordered pair is not proportionate, which means they are not equal. Let's see how to turn the tables. When we create tables for graphing, I like to create them vertically. Then the input and output values are already listed as ordered pairs. So this table here becomes this. It's the same table. Instead of having it written out horizontally, it's now written vertically. That actually makes it very easy. All you have to do is put parentheses around the numbers to create ordered pairs. So now I have an XY of 1, 3, 2, 6, 3, 9, and so on. At this point, we can graph it. Let's make sure we label our X and our Y axes. And we also need to label the units. So I'll have a 1, 2, 3, 4, 5, and it would keep going. Up here on the side, I'll do 1, 3, 5, 7, and so on. So our first ordered pair occurs at 1, 3. Our second ordered pair occurs at 2, 6. Then we have a 3 on the X, 9 on the Y, 4 on the X, 12 on the Y, 5 on the X, and 15 on the Y. You can see that actually creates a straight line. And the beauty of this is if I continue looking at the graph, I can see then that 6, what value that would land me on, and 7 and 8 and so on if I continued this graph. Now let's take a problem, create a ratio table, and graph it. Ellen is shopping for supplies at Jake's party store. We want to make a table to show how much Ellen will spend to buy 3, 6, 9, or 12 balloons. Then we'll plot the ordered pairs in a coordinate graph and use the graph to find out how much Ellen would spend if she wanted 18 balloons. So first, we look over here, and it says the cost of balloons are 3 for $2. Now let's see. If we want the 3 to turn into 6 here, that means we will multiply it by 2. So on the other side, we will also multiply by 2. So 2 times 2 is 4. Now let's look at 9. To go from 3 to 9, we multiplied by 3. So we will do that for the output values. 2 times 3 is 6. Now we are ready to go ahead and graph this. We do want to make sure we label everything. So I am going to go ahead and label my X and my Y axis. And then I also need to label the points along those axes. I labeled my x and y axis by 2's. So my very first ordered pair is 3 on the x and 2 on the y. So I will go ahead and put a point there. My next one is 6 on the x and 4 on the y. Place a point there. And then my last one is 9 on the x and 6 on the y. Now I'm going to go ahead and connect those dots starting at 0 to create the linear graph, which means it is a straight line. So once I've connected those points, what I want to do now is zero in on the 18 because it specifically says to use the graph to see how much Ellen would spend if she wanted 18 balloons. So I'm going to look at 18 here, and I'm going to travel up the line, and it looks like when we are at 18 on the x, we are at 12 on the y. So my answer is, if she wants 18 balloons, she would spend $12. Notice how important it was that I graphed that straight line correctly. If I did not graph that exactly in a straight line, then I would not be able to use that graph to see how much money we spent when we were at the 18. So be very careful to draw a nice straight line. Now let's look at another problem, but first I want to give you a couple reminders. First off, keep in mind that ratio tables are not always in ascending order. Ascending order means going from least to greatest. The tables may have their values slightly mixed up. For instance, if you look over here on our input part of the table, it goes 4, 12, 36, then down to 24, then back up to 40. That is not in ascending order. Secondly, the factors may not be in order. For instance, it might not be multiplied by 1, then by 2, then by 3, then by 4. It might be multiplied by other numbers. So, this problem says Mike the Muscle Man is exercising. His ratio of push-ups to chin-ups is 4 to 5. So that is the ordered pair we have first on our table, our ratio of 4 to 5. They want us to complete the table to show how many chin-ups Mike does for each set of push-ups. So let's look. First off, we can see that to go from 4 to 12, you multiply that 4 by 3. So we will do the same thing for the output values. We will multiply by 3. 5 times 3 is 15. Now let's look at the next row. To go from 4 to 36, you would multiply by 9. So on the other side, we will also multiply 5 by 9, which would give us 45. Next, we have going from 4 to 24. That would be multiplied by 6. So 5 times 6 is 30. And lastly, we are going from 4 to 40. Well, 4 times 40 is being multiplied by 10. So we will do 5 times 10, which will give us 50. Now we are ready to go ahead and graph this. Again, I want to make sure that I first label my x and my y axes, and then I want to label the graph itself. Now in this instance, I am probably not going to want to label by 1s because the values 40 and 50 are larger than the room I have on my graph. So I might decide to label by 2s or by 5s. Okay, so I labeled my table, or my coordinate plane, by 5s. And now I'm going to go ahead and graph some of my ordered pairs. My first one says 4 for the x and 5 for the y. So it's not quite going to be exactly on that line, but it will be close. My next one is 12 for the x and 15 for the y. Then I have 36 for the x and 45 for the y. I have a 24 for my x and 30 for my y. So 24 and 30 would be about there. And then my last one is 40 to 50. Now you can see that even though the input and output values weren't in ascending order, they still make a very nice straight line when I go ahead and graph them. Now there is a problem for you to try. But first I want you to notice that this is actually a double graph. So you are going to find the ratio for two variables. So it's like creating two separate tables and then combining them. We are going to have a table created for Ricardo and one for Sam. But instead of creating two separate tables, I am going to actually combine them and create one table. So let's look at the information that we are given. First, you have on the initial output, the first y, you have Ricardo. And it says that in 100 meters he ran 36 seconds. And then secondly, for the next output table, you have Sam. And it says for him in 200 meters, he ran 68 seconds. So it looks like for Sam's table, you are going to have to find the unit rate before you can complete his output values. Don't forget to label your graph. I labeled my x-axis in 25, so it goes 25, 50, 75, 100, and so on. And that is going to be the meters. And then the y-axis I labeled in tens, 10, 20, 30, 40, 50, and so on. And that is going to be our time for each individual runner. Now go ahead and pause the video, find your unit rate for Sam, complete his table, complete Ricardo's table, and then graph it. When you hit play again, the answers will appear. Ricardo's table is simple. We already have his unit rate. 100 meters is 36 seconds, so I add 36 for each successive row because we can clearly see that the multiplier to go from 100 to 200, they multiply by 2, and then our factor becomes 3, and then our factor becomes 4. For Sam, I need to convert that 68 and 200 to a unit rate. So instead of looking at 200, I'm just going to look at 2. 2 is 5, 2 by 2, you would get 1. So I will divide 68 by 2, which will give me 34. Now I will go ahead and plot Ricardo's points. Okay, with his points plotted, next I'm just going to join those on the coordinate plane to create a linear graph. Now I will plot Sam's points. Then I will join those points for a linear graph. We can see that in this linear graph that Ricardo actually would win the race, and he would win the race by, it looks like, 8 seconds. Now go ahead and do your quick check and see how well you understood today's lesson.